Good evening and welcome to my home in Selsey and a very special Sky at Night programme, the 700th, the longest running television programme in the world. This programme is dedicated to answering questions you've sent in. And with me are friends of the Sky at Night, old and new.
Well, I grew up with the Sky at Night. It is one of the reasons that I became interested in astronomy and physics. I had no idea I'd be on the 700th programme. I had no idea I'd be on any programme. So it's wonderful for me.
Well, I'm not an expert, but I'm very much an enthusiast, and it'll be my job to read out the viewers' questions, be the voice of the viewer for the gathered panel of experts on the programme. And, well, there's been one or two occasions when I've put myself in Patrick's shoes.
Good evening. Now, what I want to do in these talks is tell you about some of the interesting things you can see in the night sky each month.
Well, I've got to know the Sky at Night viewers over the years, and they're always sharp. They never let us get away with anything. So whatever questions they've asked, they're going to keep us on our toes.
Once a month, Patrick's home in Selsey becomes home to the Sky at Night. Today, we're turning his dining room into the set for this special programme. Astronomers are dropping in from all over the UK.
Hello, Patrick. Yeah. We've met before.
We met once years ago. How are you?
The Sky at Night viewers have sent us over 1,000 questions, and the experts are here to answer them.
Patrick.
Yes. Hello.
Hello. Nice to see you again.
First up, Professor Alan Fitzsimmons for your questions on the solar system.
Welcome to everybody. Glad to see you here. Right, take our first question.
Here it is from John A. Tompkins of Skelmersdale. If all the planets in the solar system were formed from the same cloud of material by a similar mechanism, why are they all so different, in particular Saturn?
Well, of course, we've got 8 planets, or at least now we have 8 planets in the solar system. And we can, first of all, split them up into 2 groups. We've got the rocky planets that are closer to the Sun, Mercury, Venus, Earth and Mars. And then further out, we've got the giant planets, Jupiter, Saturn, Uranus and Neptune. Yeah. We think what we're seeing there is kind of a relic of the time when the planets formed, because when the planets were forming, coming together from the disk of material swirling around the Sun itself was also forming. And in its very early days, it went through a very energetic phase. And during this phase, the star is very luminous. It emits copious amounts of energy. And that has a dramatic effect on any disk of material surrounding it. The material closest to the star is simply swept out of lighter elements. So if a planet's forming, the rocky elements, the heavy elements, can stay there and they can form the planet, but there's not much gas left around to form the atmospheres. Whereas further out in the solar system from the star, there's much more gas left there, and that can accrete onto the forming planets, and they become giants, the giant planets that we see today.
But we've seen some exoplanets, so planets around other stars, haven't we, where these Jupiter-sized planets are bigger, very close to the stars, these so-called hot Jupiters.
Which sort of destroys this beautiful theory.
How does that fit in, that you can get a gas giant very close to a very luminous star?
Well, what we think is we still think the gas giants form out at some particular distance from the star, but they don't stay there. In fact, there's evidence in our own solar system that after the formation, the planets moved. Not only the giant planets, but also the inner planets, such as the Earth.
Planetary migration, in fact.
Absolutely, and planetary migration is what we believe it explains the existence of these hot Jupiter-type planets close to their parent stars.
There's certainly one idea. Right, can we go on to question 2, John?
Well, I was just going to ask one thing. Sometimes you hear Jupiter described as a failed star. I mean, is that right?
Well,
No.
Well, no. We believe stars and planets may form differently. A star is purely gas. It's the condensation of a nebula all coming together and reaching such tremendous pressures and temperatures in the centre that nuclear fusion starts. At one time, it was thought maybe Jupiter was like that as well, but we now believe it has formed possibly the same way as the other planets. It's got a rocky core somewhere in the centre of Jupiter. There, but it's probably a rocky core, perhaps even the size of the Earth. So it's still right to call Jupiter a gas giant because it's pretty much gas all the way down. But at some point, you might hit a rocky surface.
There's a surface there somewhere.
Yes. You probably don't want to go there, though.
Well, fine, so let's go on, Joshua.
Right, next we have this question from Baz Pierce from Bolton. We've all been told about the fate of the inner rocky planets when our sun dies. But what will happen to the gas giants and ice giants in the outer solar system?
We should talk about what's going to happen when the sun dies. So, do you want to do
Tell us.
Some people think the sun is burning like a coal fire, but of course it's not.
No, it's nuclear reactions at the centre, in
Exactly.
fact turning hydrogen into helium.
Exactly.
And at some point, you run out of hydrogen at the core of the sun, and what will happen then is it will shift into being a red giant, so a giant star that's converting helium into heavier elements.
A red giant,
And so,
that's some bad luck for the Earth.
yes, well, exactly. Well, perhaps, because the red giants are
Bad luck
huge.
anyway, it'd be very hot.
Yes, that's true. I don't recommend hanging around that long. So we've got about 3 to 4 billion years to invent interstellar travel. So the sun will swell up to be a red giant. The outside, the surface of the sun will be roughly where we are now. As the Earth may have spiralled outwards slightly as the sun loses mass, so we may escape, but it still won't be very pleasant. And you'll have this red giant phase that will last for another billion years or so. So what happens to the outer solar system?
Well, during this time, what's going to happen is that it will be warmed up. And what that's going to mean is that at Jupiter, Saturn and Uranus, all three of those planets, that at that distance from the sun, temperatures will, for a while at least, a short while, reach the current day temperature of the Earth. So maybe you wouldn't want to live in the atmospheres of those gas giant planets, but you could set up camp on the moons and you wouldn't be that uncomfortable, though I'm not sure what you do about an atmosphere. And of course at the end of the red supergiant phase, you have the creation of a planetary nebula, which is going to be absolutely gorgeous. The final death throes of a starlight sun are beautiful. But what's going to happen is that the outer planets will spiral outwards. And so by the end of the lifetime of the sun, all the outer planets will be twice as far from the sun as they are now. And that's going to be the last final glory days of the solar system.
Not for a while yet, though, is it?
Not for a while.
We'll cover it on the Sky at Night when we get there.
Right, next question, please.
Well, I was going to ask, if we do need to evacuate come this time, and maybe evacuate to Pluto, will the human race fit on Pluto?
Isn't it still true that the human race could fit on the Isle of Wight if we all stood up? So I think we're fine. I think we've got plenty of real
We just all
estate.
have to be really friendly.
I think our message to our viewers is, don't panic.
I did enjoy
Next
it.
question.
Yeah, I loved your description, Patrick.
When the sun dies, one thing's for sure, I won't be there.
Next question.
I wouldn't take that bet.
Absolutely, absolutely. Now then, this is from Luke Butler, aged 11, from High Wycombe. Is there a heaven? And if so, which planet would it be on?
Oh.
Well, I'll steer clear of the theology, but I think the place where I'd most like to be in the solar system, I think sitting on the surface of Europa, watching Jupiter in the sky, which would be sort of this sort of size, and just sitting there. I'll have something to keep me warm. I'll have a source of food sent from Earth, please, and a bar. And I'm just going to sit back and I'm going to watch the weather on
plenty of
Jupiter.
ice.
And plenty of ice, yeah, I've got the ice, so that's fine. So that's mine. Where would you be?
I'll go for Iapetus, Saturn's eighth major satellite, because you have a lovely view of the rings from there, and a nice view of the sky as well. Interesting world, yes. Give me Iapetus.
Okay, that's fine. So you've got one of Saturn's moons, I've got one of Jupiter's. Alan?
Okay, I'm going to wimp out of the theology question as well, but
We all are.
I'm going to plump for here because I find all the planets and all the moons and all the bodies in our solar system fascinating. but I don't think any of them are quite as beautiful as our planet. And heaven is supposed to be beautiful, so if it exists, it's got to be here. And
Heaven is a place on Earth. In
absolutely, yes.
Yes, I know. It's called Chelsea.
Excellent. Good, good.
I must say my favourite picture in the history of space exploration is the pale blue dot picture, which Carl Sagan asked Voyager to take famously from, I think it was beyond the orbit of Neptune. So that's the Earth just as one pixel in a sunbeam, suspended in a sunbeam. It's very close to the sun from out there. So I might go for that view beyond the orbit of Neptune, so I could see my own pale blue dot picture with my own eyes.
I think Pluto as well, where you'd see the sun at that great distance and its moon Charon sort of dominating quite a lot of the sky. That would be enormously peaceful, I think, and just to survey the entirety of the solar system would be rather nice.
Fair enough. So we've spread out amongst the solar system between us.
Either that or Gallifrey.
Well, Alan, thank you very much indeed. Been great to have you back, and come back again soon.
It's over 80 years since Patrick first used his telescopes to look at the moon and the planets. He's recorded everything he's seen in minute detail. Astronomer Paul Abel has been going through Patrick's logbooks to show John some of the more unusual observations.
One of the wonderful things about being here is that every room is so richly full of archives. And
it is. This is my favourite room.
This is your favourite room?
This is the slide room. It's just filled with recordings going back to the 60s. But this is the shelf for me. This is where all of Patrick's observing books are kept.
His very own observing books where he would record his own observations. Oh, here's a great example.
This is a good one. This is Saturn.
The Saturn book.
There's a nice story attached to this and this particular era. When Saturn was edge on, see these little dots here?
Yes.
These are the satellites of Saturn. This was a time when the rings were almost edge on. And Patrick recorded a dot that shouldn't have been there, and later on he realised that was the satellite Janus. It was discovered, he recorded it, but didn't know he had recorded it, and so was robbed of this great discovery.
Oh, that's Sir Patrick's there. That's his discovery.
It's this little discovery, yeah, it's brilliant.
Indeed.
So, onwards to the gas giants. You remember the year of Voyager and...
Yes, of course.
All that stuff.
Course.
Well, one of the greatest mysteries about Jupiter at the time was that it was a big radio transmitter. One of the things Patrick did with 3 or 4 other amateur astronomers, I think this really does show that amateurs can do science and make contributions. You see you've got these discrete features like the great red spots and these belts. What people wanted to know was, were the radio features tied up with features on the surface? And what Patrick and a couple of amateurs managed to show is, no, it's not. In fact, the radio effect of Jupiter is entirely tied up with Moon Io, and Patrick and his team managed to show that.
Nice description just there. By the time I got home, Jupiter was treed out.
Treed out turns up a lot. Jellyfish seeing turns out a lot.
Okay.
And this mysterious Spode's law, which when everything goes wrong, Spode strikes again.
Spode's law.
Yes, or Spode has set up his HQ on Saturn tonight. That's another one I've read.
This is wonderful here. Odd things went on. We eventually persuaded the dome to move the right way, but periodically, motors whirred, mysterious lights flashed on and off, the platform creaked alarmingly, and on one occasion there was a small fire in the telescope pillar due to a short circuit. These things happen. Naturally, the driving clock went on strike, but we managed.
It's brilliant, isn't it?
Yes, if you're going to have a disaster, at least record it with some wit.
He
just
does.
like that.
All good stuff. Back to more recent times, what we now know Patrick's fairly famous for, of course, is the moon.
Oh, indeed.
One of the things he did actually discover is the crater Einstein. One of the things he used to do back in the 50s and 60s was look at the limb of the moon, the extreme edge, because as you know, the moon wobbles on its orbit around, so sometimes you can see stuff that's on the far side. And one night Patrick did manage to pick up crater Einstein and made the discovery.
Now, was that the feature that was later rediscovered by the Americans?
No, that's the Mare Orientale, and in fact that was discovered by a German chap before Patrick and the Americans. Don't tell Patrick.
Patrick discovered it properly.
He did. He puts in the mistakes as well. There's in the solar book, he's observing the sun. He says, wonderful view of the sun. Would dearly love to carry on observing. Alas, I have locked the keys in the observatory. Why put that in?
Oh, it's a nice moment that would just remind you of
Pure
the
Patrick
observations
Moore.
that day. Yes.
Well, look, there's a very young Patrick Moore with his telescope.
1952. Yes, the sky night hadn't been thought of at that time.
Patrick has used his 12.5-inch telescope since 1945 to study the moon. However, it wasn't until the arrival of space probes that he was able to see its far side for the first time.
Well, I can't yet show you any actual pictures taken from the moon's surface, but we can show you what I think is a very reliable drawing of what it may be like.
This very early Sky at Night was about that discovery. Who better then to answer your questions about the moon than Patrick himself?
And in many ways, the moon is a very strange world indeed.
Questions number 1, John.
Plenty of them, such as this from Jason Gillingham in Kettering. If the moon is covered with evidence of meteorite damage, why do we not see meteorites hitting the moon now?
Well, the lunar craters were formed by impact. We know that now. But of course, in those days, the far-off days, large objects floating around were far more common than they are now. And to see a new crater on the moon heavily hit by a fairly sizable meteorite, and that hasn't happened yet.
What would that look like as we see the moon so familiar in the sky? For it to be hit by a meteorite, what would that look like? Would there be smoke, explosions? How would it appear?
Well, a meteorite to make a very large crater would be most unlikely now. They've all been used up.
There have been some really quite clever studies looking at the dark side of the moon during meteor showers. And we normally see these things burning up as they enter the Earth's atmosphere, but cameras are so sensitive now, you actually can pick up the very faint flashes of these tiny particles hitting the dark side. I know you're reasonably sceptical, right, Patrick?
Rather sceptical.
But I think that this data looks quite convincing. So we do see the very smallest of
You may
meteorites.
be right, but I'm not convinced.
All right.
Anyway, no more large craters yet. One day, certainly. Next question.
Okay, this from Adrian Hodge in Southport. Why does the moon rotate at the same rate as the Earth?
But it doesn't. The point of what he means is something rather different. The moon spins on its axis in 27.3 days. The moon goes around the Earth in exactly the same period, and that's why the moon keeps the same face turned above the Earth. And the reason for that is quite simply tidal friction.
Isn't the moon moving away slowly as well?
The moon is receding about 4 centimetres per year, the moon being driven outwards by these forces, but it won't vanish in the distance just yet.
There'd be no more eclipses, which would be a
before
great
that,
show.
You ruin total eclipses, because as the moon gets smaller in the sky, it stops being able to cover the sun. So yeah, enjoy your total eclipses while you can.
For the solar eclipse of 1968, right in the middle of the Cold War, the Sky at Night travelled to the frozen wastelands of Siberia. The Russians initially refused Patrick a visa, but at the last minute relented, and he arrived just in time.
This is a perfectly glorious sight. There's the Garmin ring. You can see the prominence over on the left-hand side of your screen. There's reappearing sun once again. There's the sliver, and the light is coming back to the valley.
It's time for our next guest, Dr. Lucy Green.
Hi, by the way.
Oh, hello, Lucy. Nice to see you.
Nice to see you too.
She studies every flicker of the sun, our nearest star.
Well, let's have our first question about this.
And thanks to Bart van der Putten from Amsterdam for this one. Who was first to realise that the sun was just another star, like the thousands visible in the night sky?
I wasn't there.
And I don't have any clue.
Lucy.
Well, I thought that was a really nice question because it's about making that mental leap, isn't it, about what our local star is. And I was trying to find out actually who made that first mental leap, and it's quite hard to find it in the literature. So you can read a lot about the myths and the deity that was assigned to the sun. But when it comes to really thinking about the sun as being the same as all the other stars, I could track it back as far as the 16th century and an Italian monk come philosopher called Giordano Bruno.
Oh, yes.
And so he's quite famous because he was also interested in an infinite universe and plurality of worlds. And he thought that, in fact, the other way around, stars are the same as our sun, but they're just much, much further away. But then we can kind of go one step further than that, because to really be able to say that the sun and the stars are all the same thing, you need spectroscopy. So with the developments of spectroscopy in the 1800s and 1900s, that gave us the techniques and the physics to be able to say confidently, yes, the sun and the stars are all the same kind of object.
Thank you, Lucy. Yes, next question.
Okay, this from John Moore from Peterborough. Solar prominences are huge, but on what timescale does a prominence actually occur? A minute, an hour, a day, a year, or more?
Yeah, so prominence is one of the most beautiful phenomena on the sun. I mean, absolutely amazing. And they are gigantic. They stretch for hundreds of thousands of kilometres, and they're beautiful. And they don't take that long to form, actually, considering their size. So over maybe a day, you'd get a prominence forming. And you can look at them in hydrogen alpha and see them forming over this time. So once they form on the sun, they can last for week after week after week, and then suddenly erupt when we least expect
So
it.
why do they suddenly erupt? What causes the sudden change?
Well, it's to do with the magnetic fields. So the structures are formed because of a magnetic configuration that can hold the material in place, and the magnetic field evolves and it can destabilise, and at that point the structure erupts into the solar system.
That's interesting. Could you think of them? I thought of them actually as explosions, but you're saying they're not really. It's a magnetic field effect first, and then the material follows the reconfigured.
That's right.
field.
So I think about solar flares in terms of an explosion, but a filament eruption or a coronal mass ejection is different. It's just a lifting off of the material because of forces in the magnetic
They're
field.
certainly lovely to observe.
They're beautiful.
Is it true that the sun becomes 4 million tonnes lighter every second?
That's right, because of the fusion happening in its core.
Listen for a moment.
Yeah.
Between those two taps of my hand on this glass table, the sun lost 4 million tonnes. Don't worry, there's plenty left. Oh, thank you, Lucy.
We've had many questions about telescopes. Over the years, the Sky at Night has often featured Patrick's own observatories.
And it's from this dome, with this telescope, that I've spent a lot of time in the last few months looking at the planet Mars. This is my new one. I can't resist showing it to you. This is my 15.5-inch reflector, and you can see it's pretty massive. I have my own observatory at Selsey, where things don't always go according to plan. Flaming thing stuck.
Astronomer Pete Lawrence frequently uses Patrick's telescopes, and he took John on a tour.
I think this is the first time I've seen Patrick's garden during the day.
Do you know, that's a good point. I haven't been here many times during the day. Well, this is Patrick's 5-inch Cooke refractor. Have you ever seen it?
I have never met this telescope before.
You're in for a treat now then, John.
Oh, let's have a look.
I'll let you go in first.
Here we go.
I'll just take the roof off here, John.
Okay, let's take the roof off.
A roll-off roof. You can see it's got this amazing bicycle chain arrangement here.
Look at that, wonderfully mechanical.
It is.
Like a Wallace and Gromit invention, isn't it? We can see it working like that.
And unlock the telescope. And there it is, ready to be used. Patrick did quite a lot of solar observing with this. So basically pointing at the sun, and then had a screen at the back here where the sun's light would be projected on. You can see the sun's disk.
Never looking at it directly, as we
Never
always say.
ever look at the sun directly, no, it's very dangerous.
So if you've a telescope as big and as powerful as the one just across the way, why would you need one like this, which appears smaller and less powerful?
Well, I think they all have their own sort of area where they excel, really. This one's particularly good for planets.
Rather fond of these antennas too here like that.
These are the slow motion controls, so that if you line up the telescope with the finder, you can use these just to fine-tune the position of it.
I haven't broke it by doing that, have I? That's good.
So this is the 5-inch. Shall we go next door and have a look at the 15-inch?
Well, I think we should, yes.
Yeah, okay.
Let's see the telescope that this one orbits around.
That's a good way of describing
This
it.
is the moon of that one.
Okay, John.
Yes. Here we are. Well, this is the famous one, isn't it?
It is. This is the Patrick's 15.5-inch telescope, the largest one he's got in his garden. Well, this one's on another equatorial mount, so you can see it pointing up towards the pole there. So you can move it round left and right, and it follows the same arc in the sky that we had with the other one.
Yes, the semi-diurnal arc, in fact.
Good gracious, John, have you swallowed an encyclopedia?
It's a phrase I learned today and I was determined to use it.
Right,
which
okay.
brings us nicely to our questions. Now here's one from Paul Boswell from New Haven. I have a 3-inch reflector telescope with a few eyepiece lenses ranging from 20mm to 4mm. What can I expect to see with such lowly equipment?
It's not lowly equipment at all. I mean, the first telescope I've used was 40mm across, and I saw wonderful things with that. I think the trick would be to use the lowest power eyepiece, so that's the 20mm eyepiece. That gives you the lowest power and the widest field. But the moon, the craters on the moon, easy to see with a telescope like that. Jupiter again, which is up at the moment, you've got the 4 Galilean moons dancing around either side of it. You'll definitely see the disk of Jupiter and the belts running across it. Other planets are Saturn in the early morning and Venus. Venus doesn't show much detail though, it's just incredibly bright. It does show a phase, but not much detail on the disk. Deep sky stuff again, there are lots of clusters up there. You've got the Seven Sisters cluster, you've got the Beehive cluster in Cancer, that's a lovely sight, and also the Orion Nebula again. You must have a look at the Orion Nebula.
Now, this from Gary Walker in Banstead. If the star Betelgeuse explodes as a supernova anytime soon, would it be hazardous to the human eye to observe it with amateur telescopes?
No, I don't think there would be a problem there, but it would be, or could potentially be very, very bright. Betelgeuse is the star in the upper left-hand corner of Orion. It's what's known as a red supergiant star, and it's running out of fuel, basically. So what astronomers think is going to happen to it is it's going to turn into a supernova. I think the biggest problem is going to be the fact that the constellation of Orion is going to change as a consequence of it going supernova. Betelgeuse literally means armpit of the central one, so Orion's going to lose his armpit.
Sort of get a shoulder pad instead. Now then, this from George Brown at Westeros in Scotland. When viewing images through my telescope, everything appears black and white. Why is it that the Hubble images I've seen are always in glorious colour? Is the colour real or added during image processing?
Basically, for a sort of average amateur-sized telescope, if you look at an object, a deep sky object, like a nebula or a galaxy, there isn't enough light coming through to stimulate the colour sensors at the back of your eyes. You see it in glorious monochrome. Hubble uses filters to take monochrome pictures, and then these are combined in a way to produce a full colour image. So the colours aren't false, they are just through different filters and then put together in a certain way.
Well, that's good to know anyway. No cheating with Hubble. And at the end of that round, Pete, you've scored 28 points.
Yes.
So we're going to miss the pass.
Dr. Lewis Dartnell is an astrobiologist.
Hi there, Patrick. How you doing?
Nice to see you again.
Good to see you again.
It's his job to work out if there's life out there and where the aliens might be.
Well, what question have you had sent in about this?
Now then, this comes from Morgan in Taunton, age 9. Do you think there is life out there like aliens?
It's a good question. It's always the children have the best questions.
And the hardest to answer.
Yeah. I think so. And I think that alien life or extraterrestrial life is a likelihood. It's probable enough, it's likely enough that it's worthwhile to go out and look for it. But I think there's a distinction between primitive life, bacterial life that could survive on places like the frozen desert of Mars, and then intelligent life that would have to be complex and big and quite fragile, like a human being. To have intelligent life, the life that might be able to have a conversation with us over radio, it would have to have a planet. Its home would have to be a planet probably a lot more like the Earth.
It's interesting to look at the shift in this, I think, over the time of the sky at night, because this used to be the astronomer's problem. Now it's a biologist's problem.
Quite.
What conditions do you need for life? If you have those conditions, if you have water, liquid water, if you're in the Goldilocks zone, what else do you need? How likely is it that life will begin? Yeah. And then maybe it will become a sociologist's problem.
I think myself, the key may be Mars. If we find any trace of life on Mars, and can prove it's not Earth contamination, that will show that life has appeared in our own solar system on 2 planets.
2 neighbouring
planets. And
planets,
that will be a pointer to the fact that life is gone.
Absolutely.
What I think is very interesting is that we do see complex carbon chemistry, don't we, out there in space? I mean, amino acids in the meteorites, the building blocks of life. So it seems that the building blocks are common throughout the solar system, at least, doesn't it?
If there's life, it will appear. Will intelligence appear?
Well, this again is.
It hasn't on the Earth.
Not yet.
It's not intelligence you care about, it's technology.
Yes.
Well, the technology that would allow us to communicate.
Yeah, life that would make itself conspicuous in the galaxy, that would have industry or be beaming signals towards us. Right. And by your own definition, we weren't intelligent until about 50, 60 years ago when we started beaming radio waves and radar and television.
I thought you were going to say when the sky at night started.
Does life have to be carbon-based? And does it necessarily always need liquid water? Or is that just because what we're most familiar with here?
Perhaps it's being a bit blinkered and kind of egocentric. We're water-based and carbon-based. So the first good point, I think, is that, well, we know that works. We're a good example of it. So maybe it makes most sense to go for stuff that A, we know works, and B, we'd be able to recognise if we went to Mars or Europa.
Carbon has a lot of advantages.
Yeah.
It makes more bonds and more different types of bonds than anything else. It's stable, so there are good reasons to think that we chose well.
They look like us. I mean, there's not much outward resemblance between a jellyfish and a man. They're both carbon-based.
This is true.
One point that strikes me here, every time we try to make ourselves important, we're not.
Nature pushes us back down on our bottom again, doesn't it?
We have life here, and we thought the Earth was the centre of the universe, then the Sun, then our galaxy. Well, that's not true. We are a very unimportant unit.
Yeah, we can keep getting demoted.
In our galaxy, 100,000 million stars. We can see 1,000 million galaxies. That's only part of them. And I can't believe in all that host we are the only example of technological
There's a lot of lottery tickets out there.
I don't want to look up at the 100 billion stars in the 100 billion galaxies and think that we're unique. I think there's something slightly scary about that prospect.
One of the great frustrations, I feel, is that this is one of the biggest questions, if not the biggest question you can ask. We suspect there may be alien life on Mars, and yet we have not dedicated a mission yet to go and look for it. I know that ExoMars, the joint NASA-ESA mission, is going to go.
We have.
And what is the date for that? 10 years?
2018 looking for launch.
2018.
As you say, it has slipped a little bit.
If we ever do discover it, it will be the greatest discovery of all time from every point of view. And I'd love to see it for some on the sky at night. Well, I'd love to try it. Lewis, thank you very much.
Thank you, Patrick. Always a pleasure.
Now, Patrick, many of the questions that have been coming in have been all about you and your home here in Selsey and your collection of astronomical artwork and your many, many books. And we have unearthed an old edition of The Sky at Night on Betamax Video, which gives us some rather nice clues into how you got started in astronomy.
Oh dear.
Good evening. I say, how terribly interesting. Now, let's see if everything is as it should be. That's one of mine, and that's one of mine, that's one of mine, that's one of mine. Oh, that's one of Arthur's. Bless him, still doing his mysterious world, chasing yetis. Now, as you know, at the time of the very first edition of The Sky at Night, in 1957, I was most reassured to meet a future version of myself from the 50th anniversary of the programme in 2007. This was very, very encouraging and very charming indeed. And so now, if my calculations are correct, and they usually are, this should be around about the time of the 700th edition of The Sky at Night in the year 2011. So I thought I'd come to that very special anniversary from my very special anniversary in 1982, the 25th anniversary of the programme, and see if I can help my future self out once again. I think that should be very, very splendid indeed.
Good Lord.
Well, 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 Patrick, how very terribly nice to see you once again.
Nice to see you. What year do you come from?
1982, time of the 25th anniversary of The Sky at Night.
That was a good year, wasn't it?
Very, very good year.
Yeah,
very
I know,
good
it was indeed.
So,
yes,
for the 700th edition, I understand we are trying our very, very best to answer the very intelligent questions from our intelligent and dedicated viewers.
Yes, let's see what they're after us.
Yes, let's see the nature of the questions being asked in 2011. Graham Hall from Barry. Sir Patrick. Oh, are we a sir now?
I am now, but I wasn't then.
No, I'm looking forward to that. Excellent.
Yeah.
Sir Patrick, if you were offered by NASA, would you swap your 700 programmes in return for a one-way trip to Mars?
No, a two-way trip might be different, but a one-way trip definitely not. I mean, I'm fascinated by Mars, but it's not the place I want to stay to for very long, I don't think.
Yeah, I think that's absolutely the right answer. John Roach of Aberdeen, thank you for your question. Is Sir Patrick really the only living human to have met the first man to fly, to go into space, and land on the moon?
I can't be sure, but I think it probably is true. The first man on the moon, Neil Armstrong, I know, of course. The first man in space, Yuri Gagarin. And finally, Orville Wright, the first man to fly. And I met him when I was learning how to fly at the very start of the war, way back in 1939-40.
Yes, Orville Wright, a very mild man of great humility.
Very much so.
Next, from Ellen Hartmeyer in Amsterdam, the Netherlands. What are the cartoon-like pictures that can sometimes be seen in Sir Patrick's office. They seem to be very strange creatures.
They are indeed.
They are
Drawn
indeed.
by my mother, who was a very clever artist, and she said, no one can say that I'm wrong, and all her creatures are nice-looking creatures. They're benevolent.
They
They're
are.
not horrid.
Very benevolent aliens indeed.
She had the music and the art. I got the music. I didn't get the art.
Let's have another question here. This from Adrian Asprey from Tamworth. First of all, many congratulations on your 700th episode. You rock. What a modern term. Now, if there was one thing you could have an answer to regarding lunar observations, what would it be? What has had you scratching your head after all these years?
On the moon, we see these transient lunar phenomena, TLP, little glows. We're still a bit uncertain of what they really are. They're there all right. Just what causes them, we're not sure of that yet, even now.
Still don't know. So thank you for your question, and that is the answer to it. And finally, from Michael Murphy in County Fermanagh, what has been your greatest achievement over the last 50 years of doing the sky at night and your career?
I've tried to do one thing, to interest other people in astronomy, show them what a marvellous study it is, bring them into it as a hobby, possibly as a profession, and give them something really to enrich their lives. That's what I've tried to do. Whether I've managed it, well, that's for others to judge, but I've done my best.
Absolutely. Astronomy, the greatest of all the sciences, and anyone can try it.
Well, Patrick, thank you very much. You know, perhaps in 30 years' time, we'll be doing this program again, and this time, I'll be you.
I do hope so, and that would make me very happy indeed. I shall return to the 25th anniversary. I wish you all the very best, not only for the 700th episode, but also for your 55th anniversary next year in 2012.
Thank you very much indeed.
Many congratulations, and as always, it's terribly nice to meet me.
Nice to see you, Patrick.
And you, Patrick, as well. Until next time, God bless. Good night.
Patrick, thank you very much.
No, thank you, Patrick.
Yes, well, I've enjoyed talking to myself.
Yes, our other selves.
I wonder.
How do you do?
The first Sky at Night was broadcast in 1957, just before the launch of the first satellite, Sputnik. Since then, we've sent telescopes into space and landed robots on other worlds. Professor David Southwood leads Europe's missions to the planets and beyond.
John, can we have the first question?
We can indeed, Patrick, and it's from Ashley Bradshaw from Preston. What is in store for this century of space travel and exploration?
Oh, everyone's going to have different ideas here, but I think you must start, David.
We're going to explore Mars. We've got now a new program of exploration we've agreed with the Americans. I guess I would really like to see human beings going further than the International Space Station. I would like to see the adventure pick up from where we at present seem stalled.
Yes. Chris, what about you?
I think in the next year or two we're going to find Earth-like planets. We may have the first ones already. And several of those may be within a few hundred light years. And I think if it takes 1,000 years to launch a simple probe there, I think we should launch that probe and then wait. But I'd like to see humanity send our first probes out towards the stars.
Anything to add to that?
I would like to see a manned mission to Mars for many, many reasons. One is that it's probably the most likely place that we may find microbial life, other than Europa perhaps. It's probably easier to send a manned mission to Mars than to drill through the surface of Europa, I don't know. But also, I mean, if you look at Apollo, I genuinely think Apollo was the greatest human achievement in many ways. And I know that people will say, well, it wasn't worth the money. But I've read reports that have said that for every dollar invested in Apollo, 14 came back into the US economy. It's obvious to me that's true because the inspirational value of Apollo was immeasurable. And so I think that you measure manned spaceflight by different... You don't really measure it even in scientific terms, actually. You measure it in inspirational terms.
Emotional terms.
Yeah.
Is it true that you think once we are much more established on Mars, do you think we should start terraforming it and try to melt the polar caps and make it more Earth-like, or is the Martian surface a very precious thing? Should we leave it as it is?
I find this a very difficult question because, I come from Devonshire. People went from Devonshire all over the globe, and I'm afraid they Devon formed if they didn't.
As long as we don't do that to Mars.
You're outnumbered.
Anyhow, what I would say is I want to keep things as pristine as I can till we've done the fundamental science. I will buy that completely. But I should accept the fact we humans are part of the universe and we interact with it. It's a two-way process. The universe is changing us. We will change it. We can't avoid it.
Well, if I might give my own ideas, I would like to see a probe to Mars via Dymos. I also want to see a proper lunar base. We'd learn so much from it, and it would have to be international also. I hope it'll happen. After we get 50 years, I'll tell you. David, thank you very much.
Our next guest is the Astronomer Royal, who's joining us to answer your questions about the universe.
Yeah, you've got the message, yes. Good.
But first, Professor Martin Rees has a cup of tea and talks telescopes.
Where is that?
Probably near to Paranal in Chile. But,
Yeah.
very, very close to where the VLT is.
Right, everybody happy? Okay, right, we are recording. Okay, Patrick?
Well, over the years of the Sky at Night, we've touched on dark matter and similar topics quite often. But when we called in for our questions, and over 1,000 came in for this programme, the most popular by far was cosmology. Right, can we have our first question, please?
Here it is from Alex Andrews of Oxford. Where exactly is the centre of the universe, and where is our solar system and galaxy in relation to it?
Yes. There's no place in our universe which is more central than any other place. This is, I guess, what's called the Copernican principle, which does seem to be obeyed by our universe. Every part seems to have had the same history as every other part.
Am I wrong here, Martin?
Yes.
When I'm asked that question, I say the Big Bang happened everywhere.
Well, indeed, it was one point, but that point has now had its aftermath everywhere, so we can't localise it at all.
No.
We're not in a central position.
One of the most counterintuitive things I think cosmologists say to me is that so if the universe is infinite now, which it may well be, probably is, then it was infinite then. It was born infinite, wasn't it?
But with
in that
everything in one
sense.
place.
All the space that's here now was there then.
In effect, because we don't quite know whether the universe is infinite or just huge but finite.
Yeah.
But it could still have been infinite even if it was really tiny.
Yeah.
Well, I maintain, I may be wrong here, that we're stuck either way. Either the universe is finite, or else it isn't. If it's finite, what's outside it? Say nothing. That's speaking of the question. If it's infinite, you've got to imagine something that goes on forever. And I personally can't do that.
I love it when astronomy gets so exhaustingly confusing like that. That's a
Question
wonderful thing. What is our universe expanding into?
Oh, yes.
Well, here again, the issue is our universe infinite or not? If it's finite, then it must sort of close up on itself. So the analogy people use is the surface of a sphere like that, where if you go on the sphere, you just go round and round, you don't get to an edge. And similarly, one dimension up. Many people think that the universe could be finite, but have no edge. So it would then be finite and it would expand, just as you could imagine that whole sphere being expanded.
An added complication is one of the things we're looking for at CERN on the speculative end is extra dimensions in the universe. Those are real. There are real theories that predict or suggest there may be extra dimensions, and that would mean that what we call our universe now is a sheet. Could be a sheet, a four-dimensional sheet floating around in a higher dimensional box. Which
well, that's right. The dimensions in string theory are normally thought to be very tightly wound up, so they only affect at small scales. That may not be true. They may be detectable on the scales measured at CERN. But then, as you say, there is the idea that perhaps our universe is, as it were, alongside another. You can imagine this table and a parallel table up here, and ants crawling around on this table. We think they're in a two-dimensional universe. They wouldn't be aware of another population. And likewise, one dimension up, there could be another universe just that far away from ours. But if that distance measured in some fourth spatial dimension, and we're imprisoned in our three.
One nice thing about that, it's still speculation, but this is a potential explanation for why gravity is weak compared to the other forces, which is something we'd like to try and understand. But if you allow gravity to leak off your universe and exist in these other dimensions, then you've explained why to us gravity appears weaker than the
Going into
others.
very deep water, so
It could be very shallow water, but in an extra dimension.
It's much more fun when we don't have the evidence, Patrick. We can speculate.
Well, the next one we have from Peter Burgess of Gloucester. How does gravity bend light if photons have no mass?
Well, photons have energy, not mass, but I think that's a kind of question that Newton would have worried about when he thought of gravity as the standard inverse square law, etc.
I mean, I think
my own definition of gravity is quite simple. Gravity is the force that gives mass weight.
But I think it's the most incredible thing, the ultimate example of Einstein's theory, is that if I take this glass now and drop it, everything falls at the same rate in a gravitational field. If I take a laser and fired it in that direction, if there was enough ground, it would hit the ground at the same time as the glass, because light falls at the same rate in a gravitational field as everything else.
Yep.
The point is, though, that it goes 186,000 miles a second, so if this took a second to hit the ground, it would have missed the Earth. But if the Earth were big enough, it would hit the ground at the same time, because it travels through the same curved space.
And the fact that everything falls at the same speed is a natural consequence of Einstein's theory, whereas to Newton it was not obvious.
Fascinating. Right, John.
How are you doing, John? Are you okay?
It's fascinating.
This must be in Tom Baker's voice now.
Yes, very well. Simon Hewitt of London, thank you for your perspicacity in asking this question. Will black holes eventually swallow up everything?
Well, Martin, will they?
Yes. We don't think so. They'll gradually swallow up the material around them, but most material won't fall in for two reasons. Either it's expanding away from them with the rest of the universe, or it's orbiting around them. And it won't be able readily to lose all its angular momentum. So it's pretty unlikely that everything will fall into black hole, but certainly more will. But then, of course, black holes don't live forever. According to an idea that Stephen Hawking worked out, black holes themselves gradually evaporate away. So in the very, very far future, there wouldn't even be any black holes.
We won't be here, and there won't be any sky at night.
But it might be a wonderful clean slate for another big bang to start everything up again.
That's right.
Absolutely.
Any more questions?
Well, one that's just occurred to me, this notion that if you travel fast enough beyond the speed of light, you will travel forward in time.
Can't go faster than the speed of light.
Well, you can't get there. You can't, because the closer you get, the harder it is to accelerate.
If you're
the next bit.
massless, you'll go.
If you're
at the speed of
massless,
light.
yeah.
You can't go faster.
But I've heard this notion
If you reach the speed of light, your time stands still and your mass becomes infinite. Well, I haven't got that far. My mass is not infinite yet. Not quite. Jolly nearly, but not quite.
So the speed of light, 186,000 miles a second.
Yeah,
What
it's
is to
the
stop?
law. It's not just a good idea. That's
But
the limit.
what is to stop us when technology is there to travel 186,001 miles per second?
It's not quite such a barrier as you might think, because although nothing can move faster than that, as seen by some observer at rest, because clocks run slow and aging occurs more slowly when you move fast, it is possible to get as far as you like in what's quite a short time as measured by your subjective clock, if you move close enough to the speed of light. So it's possible, if you go close to the speed of light, to get to the Andromeda Galaxy and come back in what to you would seem quite a short time. But when you came back, at least 2 million years would have passed here on Earth.
Oh, the most wonderful example of that is for the light itself. So the distance, the light itself between us and the Andromeda Galaxy, the time difference is zero. The distance is zero. Everywhere.
Well, yes, quite so. I'm rather stunned. What about you, John? Are you stunned too? I haven't any more questions.
Completely and wonderfully. And
any more questions for us?
Lightsabers, as seen in Star Wars. Lightsabers, as seen in Star Wars.
That's an engineering problem, John. Yeah, you're asking the wrong people.
Well, that was a marvellous discussion, and I hope everyone understood it and is now absolutely clear as to what it was all about. Martin, thank you so much. It's been a great honour to have you with us.
For our last section, we've been joined by Dr. Brian May. He started out as an astronomer before being lured away by the bright lights of rock music.
How are you?
As the Astronomer Royal left, he made an intriguing observation.
I don't know any scientist who looks as much like Isaac Newton as you do.
I enjoy that.
Yes.
That will be my after-dinner comment.
Yes.
Thank you very much. Lovely to see you.
Brian is going to help us answer some of the more general questions.
Okay, we are recording.
Let's begin with the questions. Let's have the first one, John.
And it comes from Adrian Barnard from Didcot. What inspired the panel to take up astronomy with such a passion?
This is a very easy question, and in common with thousands and thousands of other people in Britain, my inspiration was you, Patrick, of course. A little book which was in my school library called The Earth, and I borrowed it, and I think I almost never gave it back. I just read it from cover to cover over and over again, and I discovered about the formation of the Earth and trilobites and the emergence of life, and I was hooked forever. And I used to beg to be able to be allowed to stay up and watch the sky at night.
So I've forgotten that little book I wrote years and years ago.
It's a wonderful book.
Right, come on to you.
Well, it will be no great surprise, Patrick, that it was you again, but not a book this time. I sat in my first term at Torquay Boys Grammar School in the audience for a public lecture you gave on the outer planets. And you taught for an hour, and I don't remember the hour, but what I remember is what you said right at the end. You came straight to the front of the stage, and you said, well, I've told you what we know about the outer planets, but the truth is we don't know very much, and by the time any of you grow up, then we'll need to have found out a lot more. And it was the first time I'd heard an adult say, we don't know everything yet. And I thought, I want to do that. So it's entirely your fault. I still don't know much about the outer planets, though.
Right. And you came up to me afterwards and began talking to me. I thought, then we'll keep an eye on this boy.
Very kind of you to say.
Come to you.
Well, again, at the risk of being repetitive, it was a book that you wrote, but I've got it here. So I brought it with me. It's this one. It's the Observer's Book of Astronomy by Patrick Moore. There it is. And it was. I know when it was because I got it as a school prize in 1978. So I chose it as a school prize.
What was the prize for?
Unfortunately for me, I thought it was. When I remembered this, I thought it must be physics or science. It's for 100% attendance, so it's not distinguished in that sense. But yes, it was this book.
It's in the same series as the Earth.
And I also asked for that for the book that I had as a school prize. Strange enough, because I'd worn out the copy that I got from the school library. Fantastic.
Well, John, what about you?
Well, Patrick, once again, it was you. And I remember being off school one afternoon with measles or something, and I watched a repeat of The Sky at Night one afternoon on BBC Two. And there you were. I'd never seen any presenter speak this way, and I was fascinated. So I was inspired into astronomy and impressions as well. And that's because of you.
Well, I'm flattered. In my case, it was picking up a book, The Story of the Solar System by G.F. Chambers, published in 1898. I read it when I was 7 in 1930. Right, next question, John.
One here from Chris Sidwell Smith of Leicester. The Sky at Night encouraged me to go to university and study space science. What is required now, 30 years on for this questioner, to encourage the next generation to have an interest in astronomy as both a hobby and an academic subject?
Right, Brian.
Okay, I'm feeling rather nervous because the seat is still warm from the Astronomer Royal, so I'm feeling a little unworthy sitting here. But encouraging the line to be blurred between amateurs and professionals, I think, is very important. Of course, we can all sit with an incredible amount of computing power on our desktops now, more than was used even to send a man to the moon. And so amateurs are able to make a fantastic contribution to science and should be encouraged to do
It's the one science where amateurs and professionals can work together, where amateur work is rarely valued.
It's amazing because you can have the most powerful telescope in the world, but it can only be pointing in one place.
Yep.
And everywhere else, things are happening the whole time, which is great.
I was just going to say, I think to encourage people to become fascinated with astronomy is watch for a solar eclipse. Try and see a solar eclipse.
We should have more of them.
Yes, exactly.
More solar eclipses.
Can you arrange that?
We'll work on it.
Well, let's go on to the next question, shall we, John?
This is a futuristic one from Geraint Day in Swindon. What do you think will be the most likely topic for the 1000th edition of the Sky at Night programme?
It'll be Patrick saying, I don't think I can do this much longer. Like he was saying 20 years ago.
Well, I won't be here, but
I think we'll be talking about how we don't understand the expansion of the universe. I don't think we'll understand why the universe is speeding up. I think that will still be a huge question.
I think we'll be looking back at the discovery of the nature of dark matter from the Large Hadron Collider within the next couple of years. I think we'll know that.
Maybe a broadcast from a lunar base.
Yeah, that would be nice.
Yes, I'd like that. That is possible. Come now to the next question. What is it, John?
This one comes from Mark Ike of Birchington in Kent. After all the previous shows, can you pick a highlight, or is there an episode, Sir Patrick, that sticks in your mind that has a real wow factor?
Shall I begin this one?
This one's for you.
The first photograph back from the other side of the moon. The Russians had said they'd send them over as soon as they got them from the probe Lunik 3, which was going around the moon. And they had used my charts, and they promised to send the photographs, and they did. And I was actually on the air live when they came through. So that was a great moment, I must say. What about you?
I think it would have to be the first moon landing.
Yes.
I was down in Cornwall with my drummer, Roger, and in his mum's house, and we just sat there watching a TV screen about this big, and there you were. And it was all very unreal. I think about it a lot, and it seemed like the most unlikely and sort of modern thing that could possibly happen. It's a long time ago now, isn't it? You know,
it is indeed.
But that's an unforgettable moment, and I think it's one of these things everybody knows where they were at that instant when it was one small step for mankind and one giant step for mankind, or whatever it was. I think he was slightly confused as well, wasn't he? But wonderful. I'll never forget that time.
We were seeing things actually as they happened, or rather 1¼ seconds later.
What about you?
The night Huygens, the probe landed on Titan,
Yes.
and I was at mission control, and because we'd already got to know the scientists, because we'd had them on the Sky at Night, we just stood in the corridor more or less and grabbed people as they came past as this story unfolded of a probe that they'd built landing on Titan and sending back the first images from this wonderful world.
As yet, we've still got no scientific data from Huygens. And there it is!
We have seen the impact of the probe with the surface directly from 2 sensors.
That's not my favourite bit. My favourite bit didn't get on camera. Just outside, there were a bunch of amateur astronomers with telescopes pointing at Saturn. And there was this line of scientists and engineers who'd built the thing that had landed on Titan, but who'd never seen Titan. And they were going up one by one and just looking. And I thought that summed up the Sky at Night, the professional and then the amateur telescopes. I think having both at once was a wonderful moment.
Well, I did have a letter once from a distinguished astronomer, whom I won't name, who made an important discovery of a nova. He'd made a completely independent discovery of Saturn. What about you, Abhijit Power?
This is my first Sky at Night. So, as far as I'm concerned, this one is my favourite because it's my first.
What about you?
Well, I do rather love those moments where things perhaps don't go to plan, and that brings out your wonderful sense of humour.
I can't see a single star at the moment.
It's totally obscured.
I remember phrases like, oh dear, we're completely clouded out, oh dear.
It's coming out, yes, there is the moon, I can see it for the moment. No, it's gone again.
It's gone. However,
absolutely infuriating, and there's nothing one can do.
Well, never mind. These things happen and we can't control it.
No telescope yet built will show a star
It's
as anything
gone,
except point of light. Is it gone? Oh, no.
just as I got it on the cross wires, it blacked right out.
How absolutely typical. There's nothing we can do about it.
I can't move a 24-inch telescope quicker than that.
No, I'm afraid you can't.
And you've got a wonderful sort of stoicism when things don't go to plan. I think that's a wonderful quality of yours that I always admire.
Well, I feel very honoured. So I hope you've enjoyed our 700th Sky at Night. An anniversary and quite a record, I think.
Your questions have been both challenging and illuminating. With over 1,000, we've barely been able to scratch the surface. But go to bbc.co.uk/skyatnight and you'll find answers to a few more of your astronomical queries.
Well, end of one era. And now, next month I come back and we have the first programme of our next 700. So until then, good night.
Coming up next this evening here on BBC4, we're heading back to Harvard to explore the nature of justice with Michael Sandel.